Everyone, welcome to Irfan CFPS YouTube channel. This is our first class for CFPS course. In today's session we will discuss about section 16 and the topic is water based fire suppression equipment. It consists of subsections such as principles of automatic sprinkler system performance, automatic sprinklers, automatic sprinkler systems, hanging and bracing of water-based systems, sprinkler systems for storage facilities, residential sprinkler systems, ultra-high speed water spray systems, water mist fire suppression systems, water spray protection, standpipe and hose systems, care and maintenance of water-based extinguishing systems. All these sections we shall cover in today's session. So kindly note that this section 16 covers 20% of the questions in CFPS examination. Basically, please make a note that our course which we are continuing today, we shall go through some of the very important points, since it is very difficult to cover whole topics in our session due to time limitations. So just we will start now. Water based fire suppression equipment. So here in chapter 1, which is principles of automatic sprinkler system performance. Okay, before we start this section, just I would like to remind you, if you want to know about CFPS examination details, course content and so on, you just go through my CFPS video, and the title is how to become certified fire protection specialist. I will keep that link in the comment section. So let's come into our topic. Chapter 1 refers to the principles of automatic sprinkler system performance. Here in this we shall go through the thermal response and water distribution and spray cooling characteristics of sprinklers, and also the difference between fire control and fire suppression by sprinklers. So in chapter 1 we shall cover these topics. One more thing I would like to highlight you, that you should not memorize any of these points, since CFPS examination is an open book exam. You just need to have an idea of the topics where you have to find in the book. For example, if you find a question on automatic sprinklers, then you should have an idea that it covers under water based fire suppression equipment, and the section will be 16.2. So just you can go to this chapter or section, and then you can find related to the automatic sprinklers. So here once again in chapter 2, in automatic sprinklers chapter, we shall discuss about the temperature ratings, water discharge characteristics and so on, and also types of sprinklers. And in chapter 3 is related to automatic sprinkler systems. It covers various topics such as system components, installation requirements, design considerations, as well as plans, calculations and system acceptance. Chapter 4 refers to hanging and bracing of water based systems, which covers topics of hangers and supports, etc. And chapter 5 is related to the sprinkler systems for storage facilities. In this we shall discuss about the commodity classification and storage arrangements and heights and clearances requirements. And also in chapter 6 is specifically dedicated for residential sprinkler systems, which covers various topics of residential sprinkler standards and type of residential sprinklers, etc. And chapter 7 refers to highly specialized type of systems, that is ultra high speed water spray systems, which is available for explosion protection and there are various systems included in this, such as squib actuated systems, pilot actuated systems, and portable systems. And the use of water mist systems is available in chapter 8. So chapter 9 refers to water spray protection, and water spray protections have typically been provided to protect a specific piece of equipment with surface coverage. Chapter 10 refers to standpipe and hose systems. Outside hose systems are also reviewed here in this chapter. So finally, this section concludes with treatment of system inspection and maintenance. So chapter 11 will be covering the activities that are central to system reliability, and among other topics, the chapter also covers sources of obstruction in sprinkler system pipes and methods for flushing and cleaning, as well as sprinkler leakage and water damage. So just we will go through the important points in section 16, chapter 1. Chapter 1 refers to principles of automatic sprinkler system performance. On right hand side of this fire protection handbook, you can find the topics which are covered and the key terms which are covered in this particular chapter. So in principles of automatic sprinkler system performance, so you just need to remember here, performance means you will have the thermal response characteristics and the spray characteristics of the automatic sprinklers. So just you need to have this in your mind. So first topic here, referring to thermal response of sprinklers. So basically we need to have an understanding of heat production and movement in a fire, which is the important or first step in analyzing the way fire sprinkler systems work. So thermal response of sprinklers is very important topic. So here you have convective heat flow in fires. Since combustion is an exothermic process, burning fuels produce heat. So even smoldering fires produce heat, although the level of heat can be so low as to be ineffective in actuating thermal detectors. However, smoldering fires generally develop to a flaming stage before producing untenable room conditions. Once the fire reaches the flaming stage, the heat release rate of the fire will grow in a manner related to the nature of the fuel and its arrangement, the ventilation conditions, and other factors. So heat is released in several forms from fire, such as radiation, conduction, and convection. So whenever you have a question in your exam related to the thermal response or the radiation, conduction, or convection, you need to check in section 16, chapter 1. So here they have shown some figures, which is the determining the heat transfer in activating the sprinklers. So here I have highlighted the handbook, so that we'll cover only these highlighted points, which are the most important points related for your examination. So here there is one a term called as RTI, which is response time index, which is a measure of sprinkler sensitivity independent of velocity. Here you have the graph which representing the time constant for constant temperature condition. So these graphs might not be used or might not be asked in the exam. However, you need to go through all these details. Here, water distribution and spray cooling characteristics of sprinklers. So as we already said that in chapter 1 related to the performance, so you have thermal response of the sprinklers, which covers radiation, conduction, and convection topics. Apart from that, you have water distribution and spray cooling characteristics of these sprinklers. So as per NFPA 13, a 7 psi operating pressure is considered minimum. So here you can see the spray pattern versus discharge pressure. This here the spray pattern, you can see various spray patterns here, and apart from this, in next page we have the fire control by sprinklers. So the traditional method by which sprinkler system control fires currently is being termed as the fire control approach. So whenever you see the question related to the fire control approach, so you just come to section 16 chapter 1, you will find the answer. This method anticipates that a certain number of sprinklers will be opened surrounding the fire area. Okay, so this is the spray pattern of the sprinklers, and here the representation of fire control by sprinklers, heat release rate versus time. So we have density area curves. This is the most important topic. You will find in several other places in the handbook as well. However, in this chapter 1 also you will find density area curves. Density area curves, we have a graph on next page. So here on left hand side, on y-axis, you can say area of sprinkler operation in square feet. Here in square meter they have mentioned here. On the x-axis you have density in GPM per square feet or density mm per minute. So we have various kinds of hazard occupancies we will discuss in the later chapters. However, here just we will go through about these occupancies. So for light hazard occupancies, we have the density as 0.1 GPM per square feet at 1500 square feet area. Okay, and for ordinary hazard occupancy, minimum requirement is 0.15 GPM per square feet at 1500 square feet area. For ordinary hazard group 2 also 0.2 GPM per square feet at the rate 1500 square feet area of sprinkler operation. And for extra hazard group occupancies, you have 0.3 GPM per square feet at the sprinkler area of operation, or the design area or the hydraulically calculated area shall be 2500 square feet. For extra hazard group 2 occupancies also the area is same, but the density will be 0.4 GPM per square feet. This is a very important topic. You need to understand this graph. However, in future classes or future sessions we shall discuss about the hazard occupancies. Also you can find related to the classifications of hazards in my in my other course of NFPA 13, where you will get all the details about these occupancy classifications. And here we have one more method called room design method, which is also permitted by NFPA 13 as an alternate to the area density method. Please note that the highlighted points are very important. You just make a note of all these things. So you have various topics. These topics you have to go through. However, we cannot cover in one class, so I am just covering the main important points in this class. So finally you can just go through the summary that is very important for your preparation of CFPS exam. So section 16 chapter 1, principles of automatic sprinkler system performance. The summary, just I will read it for you so that it will be better for you to understand. So summary, for each chapter you have summary, just go through the summary as well. For in summary they have mentioned automatic sprinkler systems are an effective means to control fires in enclosed areas, and in recent years models have been developed to perform early fire suppression. So that's why we have early fire suppression sprinklers as well. Continued improvements in design will require a greater understanding of the scientific principles involved in sprinkler performance, whereas the thermal response and hydraulic mechanism of sprinklers are well understood. The properties of water distribution are more complex and difficult to measure. Future advances in the fire suppression and control capability of automatic sprinkler systems will be the result of additional research based on computer analysis. Just to summarize from my side, in section 16 chapter 1, the heading itself says that the topic will be principles, just a moment, we have the chapter name, just a minute, principles of automatic sprinkler system performance. So you need to remember that when it says performance, it means it is referring to the thermal response of sprinklers, water distribution and spray characteristics of sprinklers, and also most importantly the area density method. So now we will move ahead with the chapter 2. Just we will go through the chapter 2 as well. Chapter 2 refers to the automatic sprinklers. Here also you have various contents related to the automatic sprinklers. Whenever there is a question on sprinklers, just come to the chapter 2 of section 16. So here you have sprinkler history and so on, principles of automatic sprinklers, operating elements. You have the sprinkler here. In this you have some element which is used, or which will burst. Once it is burst, the water will flow from the piping to the deflector, and the deflector will divert the water. Okay, so based on this deflector, the spray patterns are varied. So in operating elements you have fusible sprinklers. There will be some filaments here in this particular area, or you have bulb sprinklers as well. So in bulb there will be some liquid. So see the figure, Grinnell Corzoid, they mentioned something like this, but this is bulb sprinkler, and these are some filament type or fusible sprinklers. Very important topics you need to go through. Deflector design, as I said, based on the deflector the spray pattern will be varied. A flowing pressure of 7 psi generally considered a minimum for development of a reasonable spray pattern. So this is an important point. Here you have some modification of the common type of sprinklers, with filament type or link type operating elements. Apart from this, you have temperature rating of automatic sprinkler. This is a very important topic you need to go through. We already covered in NFPA 13 as well. So this table you need to go through thoroughly. Temperature ratings, classifications and color coding. You might get a question on this particular section or from this particular section. So they have mentioned source NFPA 13. So in NFPA 13 course also we covered about these classifications. You can go through my NFPA 13 series. However, here just to go through in a quicker way, you can see maximum ceiling temperature in degree Fahrenheit and degree Celsius. This is the maximum ceiling temperature, and the temperature rating of the sprinklers in degree Fahrenheit and degree Celsius. Here you have temperature classification. The sprinklers are classified based on the temperature rating as ordinary, intermediate, high, extra high, very extra high, ultra high, and color code of the not the bulbs but the sprinkler itself. So uncolored or black, white, blue, red, green, orange. We will see these things in later stages. So glass bulb colors, when we look at the glass bulb also we can identify whether this is the classification is ordinary or intermediate. So glass bulb colors, we have orange or red, yellow or green, blue, purple, black. So if the ceiling temperature, for example, in general you have 38 degrees maximum ceiling temperature, then we can go with the orange color or red color bulb type of sprinklers with the temperature rating between 57 to 77 degrees centigrade. So basically we'll go with the 68 degrees centigrade temperature rating, considering the red color bulb, since that is available in the market, and that is very important topic, so you need to go through thoroughly. So here they have provided the pendant sprinkler pattern, pendant type of sprinkler. Here you have one more table, temperature ratings of sprinkler based on distance from heat sources. You need to go through about these temperature ratings also. just you need to make a note about this as well. Rating of sprinklers in specified locations. For example, you have skylights, so intermediate degree rating you need to consider. Skylights you have so glass or plastic you know type of material to be used. So you have basically standard spray sprinklers. You can see here, this is the bulb type sprinkler, filament or link type or fusible link type sprinklers, operating element I mean to say. So different type of sprinklers you have. So here standard spray sprinklers are made for installation in an upright or pendant position and must be installed in the position for which they are designed. So these are upright sprinklers. Upside you can see upright sprinkler. This is pendant sprinkler. This is upright sprinkler. Water discharge patterns they have shown in the next slide. Just check here, installed upright. For example, if you install upright sprinkler below the false ceiling or the roof, the spray pattern will be like this. And pendant sprinkler, see, you will install the pendant sprinkler in the ceiling, so the spray pattern will be in this way. Just go through the spray patterns as well. So here recessed sprinklers, you have different type of sprinklers. In pendant you have some plate, so these are called flush type plates. You have various type of sprinkler cover plates. Here you have concealed sprinklers. So pendant sprinklers, so they are also called as pendant sprinklers, however these are concealed type sprinklers. Okay, so it says a concealed sprinkler is a type of ceiling sprinkler whose entire body including the operating mechanism is above its concealing cover plate. I think you can understand easily, since you are appearing for certified fire protection specialist exam. It means you definitely have an idea about all these type of sprinklers. You have various type of other sprinklers such as ornamental sprinklers. Okay, so they have been decorated by plating or enameling to give desired surface finishes. You have dry pendant and dry upright sprinklers as well. So basically automatic sprinklers, this is chapter 2, automatic sprinklers. It covers the type of sprinklers as well. Apart from that, it also covers the most important table about the temperature ratings. So this you need to remember. So sprinklers for special service conditions, residential sprinklers also you can find here some points. Large drop sprinklers with different type of K factors. So large drop sprinklers are special sprinklers with a nominal K factor of 11.2, or we can say K factor as 160. So you just need to remember that. On off sprinklers are also there. Apart from the sprinklers for corrosive conditions. And here you are getting an idea, I believe, that all these are covered here in automatic sprinkler chapter. So side valve sprinklers, you have extended coverage side valve sprinklers, open sprinklers, small and large orifice sprinklers. The terms small orifice and large orifice are used to describe sprinklers with orifice sizes other than half inch. So this is very important point. And high discharge large orifice sprinklers operating at discharge densities of 0.45 GPM per square feet. This you need to remember. The pattern of the water discharge from small and large orifice sprinklers is similar to that of standard sprinklers with K factor 5.6. Here you can see this is a upright sprinkler, and the operating element is removed here. The pendant sprinkler with a bulb operating element. Here spray patterns or spray sprinklers with different orifice sizes. This is an important formula, everyone I believe Q is equal to K root P. Q represents flow in GPM, so K represents flow constant, P represents pressure in PSI. As we already discussed, minimum pressure will be 7 PSI. That has to be considered as per NFPA 13, and we can find out the flow in GPM for one sprinkler or n number of sprinklers with this formula. Okay, so here this is also an important table. You need to go through thoroughly about the table as well. You might get a question from this table as well in the examination. Since you have 20% of the questions out of 100% from this section 16, you need to be very much thorough because it covers most of the questions in the examination. So table 16.2.4, orifice sizes for sprinkler smaller than K 5.6. So for 5.6 nominal K factor, or in liter per minute per bar per 1/2, the K factor will be 80. You can say K as 5.6 or K as 80. If the pressure you are considering in PSI, you just consider K factor as 5.6, and the units are here. Nominal K factor, if you are considering pressure in bar, 80. So percentage of discharge at same pressure compared to K is equal to 5.6. So at 5.6 K factor, the discharge will be 100%. If you consider the sprinkler K factor 4.2 or 2.8, then the discharge will be 50% as compared to the 5.6 K of sprinkler. So this is an important table. Basically we go with if there are no specifications in the project, or if there is no specific data available, we will go with the K factor 5.6 for installation purpose of any kind of sprinklers. However, if the area limitation is much high, then we'll go with the higher K factors. Here there is one more table of K factor orifice sizes for sprinklers larger than K 5.6. So if the K factor is higher than 5.6, then the discharge percentage at same pressure compared to 5.6 will be this one. So you just have an idea about this. So apart from this, here you have some technical sprinklers, pick trunk sprinklers, okay, intermediate level sprinklers. Intermediate level sprinklers also referred to as in rack sprinklers. This is very important point. The highlighted points, as I already told, are very important. You have to go through these points before the examination. So here you have one more table, sprinkler discharge characteristics identification. Here you have the K factors, okay, and here you have seen the percentage of nominal K is equal to 5.6 discharge. This discharge percentage at 5.600, and the orifice size is, or thread size is, half inch. So half inch NPT till 5.6 K factor. For K factor 8 and 11.2, you might go ahead with 3/4 inch NPT or half inch NPT. In both this you have the sprinklers with K factor 8 with 3/4 inch NPT or half inch NPT. This is based on the manufacturer. So this is also an important table. Here you have SFR sprinklers, specific application control mode sprinklers. So this is also very important. Intermediate level rack storage sprinklers have this kind of deflector. So in summary, just I'll read for you. This is an important point. The purpose of an automatic sprinkler system is to extinguish a fire or prevent its spread by automatically releasing a stream of water and distributing it over the protected area. The sprinklers are fed water through a system of piping and are triggered by predetermined temperatures. Several different types of sprinkler systems have evolved over the years since their introduction in the later half of the 19th century. The type of automatic sprinkler system installed and the settings used depend on many factors, including the purpose of the building, whether residential or commercial, and aesthetic considerations. As fire protection devices, automatic sprinklers have been found to be rugged, mechanically simple, reliable in operation, and generally free from premature operation. So chapter 2 itself states that automatic sprinklers. So you have basically various type of sprinklers covered here in this chapter. Apart from that, the K factors and the percentage of discharge based on the K factor is also available in this chapter. So now we will move ahead with the chapter 3, automatic sprinkler systems. So on right hand side you will find the various contents which are covered in this chapter 3. So I'll cover the important points only here. NFPA 101. See, one more thing very important. In CFPS examination, there might be definitely one question related to the NFPA standard. Maybe they might ask NFPA 101 refers to dash. Okay, they will provide some options. So you need to thoroughly go through that. You no need to memorize, but you can find in fire protection handbook about this NFPA codes. So NFPA 101, here it says life safety code. So apart from this, there are several topics available here, but these are not the utmost important topics. However, you have see, since this is chapter 3 is related to the automatic sprinkler systems, so it is focusing mostly on the type of sprinkler systems. This also we covered in NFPA 13 course. You can just go through that one, which is already available in my YouTube channel, Irfan CFPS. So here we just go through the type of systems thoroughly. So in most of the sprinkler systems fall with one of the 4 categories. So basically there are 4 type of sprinkler systems: wet system, dry system, pre-action and deluge system. Here just they have shown a network which is which will be serving to the buildings from the city main and suction tank, gravity tank. They have taken the source. So this will be connected to the building sprinkler systems. So here you have wet pipe systems, dry pipe systems. So dry pipe system, this system should only be used when system components will be exposed to temperature below 4 degrees centigrade or 40 degree Fahrenheit. This is an important point, you need to make a note. So here they have shown the figure. You can see chapter 3 automatic sprinkler system. So you have to get an idea, or you need to remember that it is definitely covering the type of sprinkler systems like wet, dry, pre-action and deluge. So this figure is showing the basic components of wet pipe sprinkler system. Here you have the branch piping with other sprinklers, and this is the cross main, and this is the riser. You can call this as bulk main or riser. Here you have alarm check valve assembly and the water supply from the underground network or from the pump. So here you have a dry type valve. So if you want to learn more about this type of systems, as I already said, you can go ahead with my video lectures or series which I already posted in the YouTube channel. So pre-action system, it's also a dry pipe system, but here it says similar to a dry pipe system, a standard or single interlock pre-action system piping is charged with air under pressure rather than water. Here you have hypothetically dry pipe system. In wet pipe system you have the water supply and water is filled in the piping. Once the fire occurs, the sprinklers burst or the bulb burst, and the water flows through the sprinklers. In dry type, these pipes will be dry till the dry type valve only the water will be available. So here you have typical pre-action system. Apart from that, comparison of operating features for types of pre-action system. Here you have deluge system, other systems. Deluge system, you have deluge valve here. This is also similar to the dry pipe system. Design objectives, they have shown occupancy hazard classification. This also covered in my NFPA 13 video series. Basically NFPA 13 defines 3 fundamental hazard levels: light hazard, ordinary hazard. Ordinary hazard also divided into ordinary hazard group 1 and group 2, and extra hazard group 1 and group 2. So you have 3 types of hazard: light hazard, ordinary hazard and extra hazard. Some of the examples which are already available in NFPA 13, here also it is shown. Like light hazard, office buildings and schools comes under light hazard. Residential occupancies, public assembly. Ordinary hazard, you have various things like dry cleaners, library, all this comes under electronic plants, everything, restaurant service areas, everything comes under ordinary hazard. Group 1, Group 2 are separately defined, as you can see in the screen. Extra hazard also divided into Group 1 and Group 2. You have various areas such as flammable liquid spraying areas, which comes under extra hazard Group 2, plastic processing Group 2, and you have printing that uses inks with flash points below 38 degrees centigrade. It comes under extra hazard Group 1. So all this comes under extra hazard occupancies. So ceiling construction, here there are two types of ceiling constructions and NFPA 13 considers. So basically you have two types. One is obstructed ceiling construction, and the other is unobstructed ceiling construction. So here just they have shown the obstructed construction. Here you have unobstructed construction. Here you have one more table, sprinkler discharge characteristics identification. This is okay, we just go through this. Here you have the nominal K factor and the percentage of discharge, and the thread, which is already covered in our earlier slides. So this is an important table. Nominal sprinkler orifice sizes. If you are considering nominal K factor of the sprinkler as 5.6, the nominal orifice size will be half inch. So in mm it will be 12.7 mm. If you are going with 11.2 K factor sprinkler, then the orifice size will be 5 by 8 inch or 15.9. This is an important table which you need to go through. Here also they cover temperature rating classification and color coding, since it is reflecting to the various sprinklers. So this table also included here in chapter 3. So pipe and tubes, you have system components also covered here, like pipes, steel pipes, copper tube also can be used, non-metallic pipes also can be used, but you can check in NFPA 13, which is the standard for installation of sprinkler system. Here in table 16.3.5 in fire protection handbook, pipe or tube materials and dimensions are mentioned, and the standard that can be used for our sprinkler system is shown here. So you have specification for welded and seamless steel pipe. If you are using steel pipes, welded type or seamless type, you need to consider ASTM A53 or ANSI standard. So here you have some other specifications for copper tubes. Okay, so this also can be used for our sprinkler system. Piping, you have system valves. So basically this automatic sprinkler system chapter 3 covers type of systems like wet, pre-action, deluge, and also dry type systems. Apart from that, it also covers the nominal sprinkler orifice sizes, and also ceiling construction types, and also the main important topic, occupancy hazard classification. Apart from that, this covers various system components such as pipes, valves. In valves you have supervisory switches as well. This is OS and Y gate valve, post indicator valve. So you can check my video series on NFPA 13 for more details about these components. And installation rules for automatic sprinkler system, they have mentioned here. There is one point, just we'll go through this. Some areas that do not require sprinkler coverage include bathrooms in residential type occupancies that are not over 5.1 square meter in area and are composed of non-combustible or limited combustible materials. Small closets in hotel occupancies are also not required to be protected with sprinklers. In both instances, there is recognition that the fuel loading in such spaces is minimal, and that fires that originate in such spaces do not normally become threatening to either the occupants or the structure. So basically they are telling that sprinklers in some areas may not be used. Okay, so here you have one more table 16.3.7. here it says protection areas and maximum spacing for standard spray upright or standard spray pendant for light hazard occupancies. Here for example you have non-combustible, obstructed and unobstructed, and combustible unobstructed with members less than 3 feet on center. For example, if you are going ahead with the pipe schedule method or hydraulic calculation method, so there are the protection area to be considered. As a thumb rule for pipe schedule, you can go ahead with 18.6 square meter protection area for one sprinkler, and the distance between sprinkler to sprinkler for pendant or upright will be 4.6 meters. For hydraulically calculated methods also, the protection area or the coverage area of one sprinkler can be 20.9 square meter, and the maximum spacing shall be 4.6 meters. Here you have protection areas and maximum spacing for ordinary hazard as well. This is very important table. Protection area for ordinary hazard, for upright or pendant sprinkler will be 12.1 square meter, and the maximum spacing will be 4.6. So for light hazard, for hydraulically calculated areas, you can consider 20.9 square meter coverage area for one sprinkler, and for ordinary hazard it shall be 12.1 square meter maximum area. So protection areas and maximum spacings for extra hazard. For extra hazard, basically for hydraulically calculated methods with density greater than or equal to 0.25, the protection area will be 9.3 square meter. So the coverage area will be 9.3 square meter for one sprinkler, and the distance between sprinkler will be 3.7 meter. Basically this will be used. However, you just go through this table as well for your examination preparation. For high pile storage also, you have 9.3 square meter area coverage for one sprinkler, and the distance between sprinkler will be maximum 3.7 meters. So here you have the design considerations for automatic sprinkler systems. Basically there are two design methods existing in NFPA 13. So the pipe schedule method and the hydraulically design method. This is an important point. Water supply requirements for pipe schedule system. This is an important table. You need to go through for this as well. Occupancy classification, for example light hazard or you have ordinary hazard. For light hazard, minimum residual pressure will be 15 psi. For ordinary hazard, minimum residual pressure will be 20 psi, and the acceptable flow at the base of riser will be 500 to 750 gpm for light hazard and 850 to 1500 gpm for ordinary hazard, and the duration for light hazard will be 30 to 60 minutes and the ordinary hazard will be 60 to 90 minutes. So this is for pipe schedule sprinkler system, which is very important subject to be remembered, and also this might be asked in an interview as well. So here once again you can see the density area curve. This already we discussed in our earlier chapter. So if you are using quick response sprinklers, there are special design considerations to be taken. So a reduction in the system sprinkler or system area of operation is permitted where quick response sprinklers are used. So when we are considering the hydraulically design area, for example you have light hazard occupancy, and the hydraulically most demanding area is 1500 square feet at 0.1 gpm per square feet. If we consider quick response sprinklers in light hazard, then the density will be 0.1 gpm per square feet. However, the area of sprinkler operation can be reduced. So the hydraulically designed area can be reduced. That can be found from this graph. So this also I discussed in our NFPA 13 series. You can go through that. So based on the ceiling height, the percentage reduction they have shown here. If the ceiling height is more than 20 feet, then there will not be any reduction in the area. So you just consider 1500 square feet area of sprinkler operation. Here we have one more table, friction loss psi per linear foot of pipe for black steel pipes. So for black steel pipe you have various sizes, and the friction losses are mentioned here based on the GPM. This is also an important table. So plans, calculations and system acceptance tests. In addition to being hydraulically or hydrostatically tested. Dry pipe systems must also be pneumatically tested for 24 hours to make sure that air is not being lost to faulty installations of fittings of pipe. This is an important point. Marine applications are also introduced in NFPA 13. You just go through this as well. So just we will go through the summary, that will be helpful. So chapter 3 here, chapter 3 refers to the automatic sprinkler systems. Here we have covered various topics, and just we'll go through the summary now. Automatic sprinkler systems serve as one of the most effective methods for providing fire protection and life safety. Sprinkler systems can be installed in various types of buildings and facilities, such as manufactured homes, high-rise buildings, warehouse facilities, manufacturing facilities, and more recently merchant vessels. Technological advances continue with piping materials, sprinklers, fittings, and hangers, both in terms of the products offered and the manner in which they are installed. Advances in technology will continue to produce more effective and cost-effective sprinkler systems for an increasing number of applications. The greatest obstacle to even broader use of sprinkler systems is public perception rather than limitations with available technology. Just to go through this automatic sprinklers system, we'll just have a look the topics which we covered here in chapter 3. This will be a lengthy session, however this will be useful for you to get an idea for your CFPS examination preparation. So chapter 3, automatic sprinkler system, we have covered various topics here, basically the type of sprinkler systems, and apart from that we have gone through the occupancy hazard classifications and the examples also for the type of occupancy hazards, ceiling constructions, obstructed and unobstructed ceiling type of construction, and the sprinkler discharge characteristic identification, nominal sprinkler orifice sizes tables, everything we have gone through. Temperature rating classifications already discussed in the earlier chapter, and system components such as pipes, tubes, and system valves like OSN type, gate valves, post indicator valve, everything we have gone through here in this and this highlighted point refers to the omission of sprinklers in particular areas, and you have the sprinkler area coverage based on the hazard occupancies and pipe schedule and hydraulically calculated methods, and the distance between the sprinklers for light hazard, ordinary hazard, and also the extra hazard occupancies. So also we have gone through the area coverage and the maximum distance between sprinkler for high piled storage sprinklers as well, or high piled storage areas as well. Apart from that we have seen there are two different design methods existing in NFPA 13. One is pipe schedule method and the other is hydraulically design method. We have gone through one table, water supply requirements for pipe schedule sprinkler systems. This is an important table. Apart from that you have density area curves, and we have seen the reduction of area if we are considering the quick response sprinklers. So this is the graph, and this is the curve, and this is the formula you have. Based on this formula we need to calculate the reduction of area while considering the hydraulical calculations. And also finally we have gone through the friction loss shown here based on the pipe size for black steel pipe and the GPM. So, and marine applications also, they are using special type of sprinklers. Marine systems are covered in the other NFPA codes. Apart from that the acceptance requirements we have seen, and finally we discussed about the summary. So chapter 4 is related to the supports, hanging and bracing of water based systems. Whenever we say section 16 referring to the water based systems, it means it is covering the automatic sprinkler systems and the related details. So here in chapter 4 we are going through the hangers and supports. So basically the maximum pipe stand heights, they have just given the pipe stand diameter and the diameter of the pipe. This table just go through, and the hangers must be listed as per NFPA 13. Hanger loads they have given, so this is an important point you need to remember. Hanger load, how much it has to support. So there are various types of hangers like swivel hanger, clevis hanger, split rings, riser clamps, pipe clamps, and so on. So just go through these U bolts and U hooks and so on. So common types of acceptable hangers they have shown here in fire protection handbook. You have trapeze hangers as well. Apart from that, you have sway support brace. There is one table related to the trapeze hangers. Apart from that, I'm just going through thoroughly for this chapter. Maximum distance between the hangers. So whenever you see a question in your exam related to the hangers or supports, you just come to this chapter, section 16, chapter 4. You will find all the details about the hanger. So for example, here this is an important table, maximum distance between the hangers. So here you can see the pipe sizes till 8 inch from 3 by 4 inch. On left hand side you have the pipe. So for example, if you are considering steel pipe, then the distance between the hangers can be for 3 inch pipe 15 feet. Okay, so we just you can go through now. So apart from that, hangers in earthquake areas and so many things are there. It's like an ocean. You just go through about these things. Here they have shown various earthquake areas and so on. So based on that, they have done some research and they have given the type of hangers and the load to be considered and so on. So joint restraint of underground piping, thrust blocks also there for underground piping. So here you can see that for underground piping as well there are supports, and especially there are thrust blocks to be used, which are large concrete blocks used to transfer horizontal loads to undisturbed soil or to resist upward vertical loads by means of their mass. You just go through all these things, and in summary we'll just go through for your clear understanding. In the development and application of rules for structural support of fire protection system piping, fire sprinkler systems have received great attention. This is expected given their widespread use, but the features related to hanging and bracing can also readily be applied to other types of fire protection systems and components, including pumps and tanks. The weight of any component required to be braced could be substituted for the weight of system piping in the application of the rules for braces and fasteners. The NFPA 13 hanging and bracing criteria continually improved over decades based on practical experience, represent the best available guidance of supporting fire systems and protecting them from earthquake damage. So there are various kinds of supports or hangers considered in earthquake areas also. So basically this chapter 4 covers the requirements of hangers, supports. So you just go through this as well. We are moving forward with chapter 5, sprinkler system for storage facilities. From here in this chapter we are looking for the sprinkler systems in storage areas. So NFPA storage standards are based on full scale fire tests and past loss experience. So here in storage application there are various commodity classification. This also I covered in NFPA 13 course. You can have a look about that videos in which are available in YouTube channel. NFPA 13 provides an approach that categorizes materials into one of 7 major categories, classes 1 through 4 and groups A, B and C plastics. Here class 1, class 2, class 3 and class 4 type of commodities. Based on these commodities the sprinklers shall be defined. So you have plastics, you have group A plastics, group B, group C plastics as well. Some of the examples are mentioned here. So basically for storage applications means you need to think that it is referring to the commodity classifications such as class A, class B, class C, or group A, group B, group C, and class 1, class 2, class 3, class 4 commodity classes. And the storage arrangement also is available here, like solid pile storage, palletized pile storage, how we are storing the material. So bulk storage, everything is mentioned here. Rack storage, and you have a bin box storage. All these details can be found here. Shelf storage, other types of storage racks. Here there are the widths they mentioned. Aisle width for rack storage up to 7.6 meter high. Aisle width significantly impact sprinkler system requirement. So basically I think you are getting an idea now that based on the chapter name itself, you are having the topics inside the chapter, or the contents are available inside the chapter. So here there is some point related to the palletized storage piles, aisle widths, and storage height and clearances. There is some graph. This also we are covering in our NFPA 13 series. You can go through that. Here you have various approaches for sprinkler protection of storage applications. These includes the use of control mode density area sprinklers, control mode specific application sprinklers, and early suppression fast response sprinklers. So you have various data related to these things in these slides. So indirect sprinklers, maximum storage height, ceiling height. Based on that, the number of sprinklers to be considered are mentioned here. You just go through these things. So no need to remember anything. Just since this is an open book exam, you just should have an idea where to find those topics in this fire protection handbook. This is the most important point. So sprinkler spacings also they have mentioned. So for storage applications, the maximum spacing for most sprinklers is 9.3 square meter, whereas extended coverage sprinklers may be spaced at 59.7 square meter for storage applications. So you have various pallets like idle pallets and wood pallets, plastic pallets, etc. You have rubber tires. So all this covers under storage topic, storage facilities topic. So chapter 5 referring to sprinkler system for storage facilities. So roll paper, carpet storage, carpet padding, all these are important topics. Pesticides, so basically baled waste paper, all this comes under storage application. So here in summary, just we will go through thoroughly. Protecting storage facilities from fire presents a particular challenge, and efficient use of space such as small flues between stored materials is also conducive to maximum burning rate and fire spread. An effective fire protection strategy needs to take into account various factors including the commodity classification, the storage arrangement, the storage height, and the clearance from top of storage to sprinklers, water supply, and construction. These factors and others determine the sprinkler types, designs, sizes, and installation arrangements of the automatic sprinkler systems. Basically this chapter 5 is referring to the sprinkler systems for storage facilities. So chapter 6, here in chapter 6, as the name itself states, it is referring to the residential sprinkler system. On right hand side you have the contents which are covered in this section or the chapter. Residential sprinkler systems designed and installed in accordance with NFPA 13D or NFPA 13R have significantly different requirements than those for residential occupancies designed in accordance with NFPA 13. So there is a separate dedicated NFPA standard or code for residential sprinkler systems. So you can use NFPA 13. However, NFPA 13D or NFPA 13R is specifically meant for residential sprinklers. So this table refers to the structure fires in homes by area of origin from 1999 to 2002 annual average. So here you can see this table. Just go through this table as well. So over 50% of home fires, over 70% of home fires fatalities, and over 70% of home fires injuries are the result of fire starting in a living room, bedroom, or kitchen. Basically these are the critical points from where the fire starts. Another aspects of the residential fire problem concerns those who typically die in residential fires. Here also the structure fires table, structure fires in homes by item first ignited. So here also there is a table, you just go through. These are all the bar charts and so on. So sensitivity testing, the test is known as plunge test. This is very important point. So sensitivity testing, this test is known as plunge test because a sprinkler at room temperature is plunged into a heated airstream of known constant temperature and velocity. So this is the testing of other sprinklers. Here you have various topics, you just go through all these things. I am covering the important points since as you can see this is taking so much time, so I need your support so that I can continue my work and post the videos on a certified fire protection specialist course. Since it takes a long time, if you are motivating me and if you are supporting me and if you are subscribing to this channel and you are visiting or looking my videos, then I'll be very much happy and it will make me move forward with the various topics in future as well. So coming back to our topic, see here there are so many things but I'm not covering since those are not much important. So basically in summary we just go through residential sprinkler systems are an effective means of controlling fire in the home, allowing occupants the time to escape or be rescued. Several different systems exist and research is ongoing to develop systems that are more efficient and cost effective. The design and installation must take into consideration or into account where sprinklers in a home are most effective in reducing the risk to life and property. The sprinkler system needs to activate automatically while a fire is small and the smoke and heat conditions in the home are survivable. Once the system is activated, it needs to control the fire with a smaller amount of water relative to a commercial sprinkler systems. Although most fire related deaths in the United States occur in the home, it is estimated that less than 3% of 1 and 2 family dwellings have sprinkler systems installed. This is the important point. So basically chapter 5 is referring to the chapter 6 referring to the residential sprinkler system. So if you find any question related to the residential sprinkler in the exam, you just come to the section 16 and chapter 6. So chapter 7 we are moving ahead and we are in chapter 7 now, ultra high speed water spray system. This is also an important topic and a unique topic which most of the people don't understand. So ultra high speed systems are used for explosive hazards. So ultra high speed water spray systems, they have mentioned two fundamental types of suppression systems are available to fire protection professionals for the control or extinguishment of explosive hazards. One is ultra high speed water spray systems and the other is explosion suppression systems. So here you have ultra high speed water spray systems are defined by NFPA 15, which is the standard for water spray fixed systems for fire protection. So they are just showing the reaction time of this ultra high speed systems, and this is an important, very important table. They might definitely ask in the examination. So this table refers to the classification of explosives. Class 1 Division 1 mass detonation includes explosives, ammunition and liquid propellants that are too energetic to be protected by an ultra high speed water spray system. So there are various classification of explosives you can find here: class 1 division 1, class 1 division 2, class 1 division 3, class 1 division 4, class 1 division 5, class 1 division 6. This is an important topic which you need to go through. General detection concerns also they have highlighted. Examples of optical flame detection devices include ultraviolet or infrared detectors. So apart from this, you have squib actuated systems, solenoid actuated systems and so on. So this is covering UV and IR detectors. Just they are showing IR detector, and UV detector. This is a figure. So basically here manufacturing operations, they just mention in general the 14 processes that describe most munitions manufacturing operations include the following. So here I highlighted one point which states that the 3 performance objectives that are to be considered in ultra high speed suppression system design are life safety and personal protection, equipment protection and facility protection, and total extinguishment or propagation cessation. So this is an important point which you need to go through. And apart from that, you have these topics: weighing, pressing, pelletizing, propellant loading, melting, extrusion, mixing, blending, screening, sawing, granulating, drying, pouring, and machining. All these are covered in this slide. You can just go through these things as well. Here you have flame detection devices, ultraviolet detectors. This is very important topic which you need to go through. UV detectors are designed to detect radiation falling within the ultraviolet wavelengths before 4000 angstroms, 0.4 microns. Infrared detectors, they have given some data, so you just go through this. Apart from that, you have squib actuated systems. It is recommended that this system be used for hazards such as ammunition loading, explosive powder drying operations, high energy fuel processing, self oxidizing fuel processing and storage, silane containment cells, explosive dust collecting and conveying operations, roll mills and casting pits. UV detectors may be unsuitable for some dusty or busy environments. So the highlighted points are very important. You just go through. So you have very very much to learn or to go through. Just I have considered few points which are most important, utmost important, and I am highlighting those points only. So you have piloted actuated systems as well in this chapter 7, ultra high speed water spray systems. So there are so many things to be checked, the detection system and so on related to the pilot actuated systems. You have portable systems, portable ultra high speed water spray systems, explosive spear high rate discharge devices. So there are so many things to go through, and summary just I'll go through for your easy understanding. A major difference exists between ultra high speed water spray systems and explosion suppression systems. Even though both systems suppress explosive hazards, ultra high speed water spray systems are used predominantly for open machine protection or room area protection, whereas ultra high speed explosion suppression systems protect enclosed vessels. Although system names are sometimes used interchangeably, this chapter helps clarify correct terminology. There is relatively little information available on practical testing of various munitions manufacturing explosive levels for differing munitions commodities and processes. However, years of successful field performance and experience, as well as system time and reliability testing, demonstrate the effectiveness of ultra high speed water spray systems with respect to the suppression of munitions explosive hazards. Artificial retardation of the normal actuation times of ultra high speed water spray systems means the difference between extinguishment and total loss of control in the explosive process. A comparison of ultra high speed water spray system is shown in table 16.7.3. So basically this chapter is referring to ultra high speed water spray systems and the classification of explosives. And you can see NFPA codes standards here. NFPA 13 refers to the sprinkler system, 14 refers to the standpipe and hose system, NFPA 30 refers to flammable and combustible liquid code, and so on. Here they have given a table comparison of squib operated, pilot operated, explosive spear, HRD and portable deluge systems. So just go through this table, and we are entering into the final chapter, I believe, water mist fire suppression systems. So as I initially told, section 16 covers 20% of the questions in your CFPS examination. So basically if you have 100 questions, 20 questions will come from section 16. So this is an important and easy section. So that's the reason I started this, for you to understand better, and also it covers the most questions in your examination. So just we'll go ahead with chapter 8, water mist fire suppression systems. Just go thoroughly. This chapter reviews the salient features of water mist fire protection systems. Application of water mist systems. Machinery spaces, pool or spray hydrocarbon fires can be fast developing, very hot, and have the potential to cripple or destroy a ship. So basically water mist systems are used in ships. And apart from that, you have turbine enclosures. So water mist systems can be used. Marine accommodation, public spaces and service areas. Apart from that, you have hotels, heritage buildings and galleries, electrical equipment rooms, computer rooms and wet benches, tunnels. So aircraft passenger compartments. So summary of water mist system features, we just go through, and it looks big. So just we'll have few points related to this. From the preceding descriptions, it is evident that there are wide variations in the objectives, fire scenarios, system details and levels of acceptance for water mist fire suppression systems. These can be summarized as follows. So they have just shown the objectives, and they have mentioned the fire scenarios as well. So general principles of water mist systems, extinguishing mechanisms. They have mentioned the extinguishing mechanism. This is also an important topic, I forgot to highlight. So the primary mechanisms are heat extraction, oxygen displacement and the blocking of radiant heat. This is an important point to be checked. And apart from that, I think there is one more point here regarding the secondary mechanism. You just go through related to this. So heat extraction, when water is applied to a fire, heat is absorbed in three areas: from the hot gases and flames, from the fuel and from the objects and surface in the vicinity of the fire. So all these are available here. You just go through mechanism of extinguishment by water mist and their application. Here you have primary, secondary mechanisms. Just go through the principle of application. Here you have radiant heat blocking. Blocking radiant heat plays a role in stopping the fire from spreading to unignited fuel surfaces and reduces the vaporization or pyrolysis rate at the fuel surface. So there are so many things to be discussed. Since the time does not permit, I am ignoring some of the points and I am covering only the major portion or the most important points which are helpful for your examinations. So spray characteristics of water mist systems. The following discussion includes all four characteristics of water mist for fire suppression purposes: drop size distribution, flux density, spray momentum, additives. This is an important question and you might expect in the examination. So you have flux density. Flux density is therefore an important characteristic of water mist fire suppression system. You have spray momentum. Three factors that constitute the momentum of the spray are spray velocity, its direction related to the fire plume, and the mass of water droplets transported into the flame or onto the fuel surface. So as I said earlier several times, that the highlighted points are very helpful and important for your examination preparation. Additives. The chemical nature of the water supplied to the nozzles influences the performance of water mist as a fire suppression. So design of water mist system, there are several points to be reviewed. Water mist nozzle design involves one of the three basic principles: impingement of a jet of water on a deflector, expulsion of a high velocity jet from an orifice, use of compressed air or nitrogen to shear water into fine spray. All three methods have been used by manufacturers of spray nozzle. Here you can see the type of nozzles. You have impingement nozzles, impingement or impinging jets. Just go through these terms as well. Pressure jet nozzles, when they are talking about the nozzles, it means water mist nozzles mostly. Twin fluid nozzles are also twin fluid nozzles are also referred to as air atomizing nozzles. This is also an important point. Nano mist is an ultra fine mist with very uniform drop size distribution with a volumetric mean droplet diameter in 10 micron range. You have other kind of nozzles such as automatic, non-automatic and hybrid nozzles. NFPS 750 introduced these terms to distinguish among three types of nozzles that are already on the market: automatic nozzles, non-automatic and hybrid nozzles. Design calculations for water mist system. There are some fundamentals and there is a table which states potential failure concerns and suggested countermeasures to improve reliability in water mist systems. Calculations involving Hazen-Williams equation, Darcy equation and Moody diagram also available for water mist systems. So basically this chapter is completely dedicated for water mist systems or water mist fire suppression systems. So here you have a highlighted point. NFPA 750 introduced some terms. The four parameters used as the basis of description are system operation method, operating pressure, application and nozzle type. These are the four basic characteristics of the water mist system design. So you have the details for this. You have various things to go through. Since this is a big topic and unique topic, you might expect a question from water mist fire suppression system in the examination. Plastic threaded sealant tape such as Teflon tape should not be used on piping for water mist systems. You have atomizing media. So system maintenance considerations. So basically this is covering everything from A to Z of water mist fire suppression system. The summary itself is so much big, just we go through few points. This chapter presents an overview of the history of development of water mist fire suppression systems since 1990. Water mist fire suppression systems discharge less water, use smaller diameter piping and have lower overall weight than conventional water spray or sprinkler systems. Water mist can be used as a replacement for ozone depleting substances such as halogens and can be used in the applications where water was not previously considered practical. Water mist fire suppression systems are used in a wide variety of marine based and land based applications, including machinery spaces on ships as well as land facilities, turbine enclosures in offshore drilling platforms, marine accommodation areas, electrical equipment rooms, tunnels, hotels, heritage buildings and art galleries. So there are so many things or so many points you need to go through. I think if you go through this summary, you will understand and you will identify the topics which are covered in this particular chapter. So recommended inspection and testing frequencies for water mist systems, you can check here the frequency. And finally I believe we covered all the chapters. And I'm sorry, there is one more thing, chapter 9 water spray protection. Yes, there are, I think there are few more chapters to be checked. So chapter 9 refers to water spray protection. We will finish this chapter or we will finish this session by completing the complete section, so that I can post only one video regarding this section, so that the viewers can easily understand and easily go through the complete section in a short period of time. So chapter 9 refers to water spray protection. So water spray protection basically can be used effectively to extinguish a fire, control a fire, protect exposures and or prevent a fire. Extinguishment, controlled burning and exposure protection. This terminology is very much important. You have to go through with these topics. Spray system description and application. Fixed water spray systems. Examples of fixed water spray systems. Fixed water spray systems are most commonly used to protect equipment from exposure, fires in flammable liquid and gas tankage, piping and equipment in electrical equipment such as transformers, oil switches, rotating machinery and cable trays, in structural supports and in conveyor systems, and the opening in firewalls and the floors through which they pass. The type of water spray required for any particular hazard will depend upon the nature of the hazard and the purpose for which the protection is provided. So there are so many things to go through. Fixed water spray system for LPG gas tanks. You can see here water spray protection for LPG gas tanks. For exposure protection of vessels, density of 0.25 GPM per square feet should provide sufficient cooling to limit an exposure fires heat input through the vessel walls to 6000 BTU per hour per square feet. NFPA 15 refers to the water spray fixed systems. Here they have shown a figure water spray system for oil filled electrical power transformers. So water spray systems are basically used for LPG gas tank protections and electrical power transformers, etc. So they have just given the sample calculation here. This table is also related to the hydraulic calculation for water spray system. So T's, fittings and so on they have shown. Other maintenance consideration they have shown. It is important that fixed water spray system shall be inspected and maintained on a regular basis. NFPA 25 standard for the inspection, testing and maintenance of water based fire protection systems provides specific requirement for periodic inspection, testing and maintenance of water spray systems. So basically summary, this is a small chapter, so summary is also very short, just we will go through. Water spray systems primarily provide fire protection for specific hazards, that is they are designed to protect specific hazards and equipment with surface coverage. This chapter addresses the applications of water spray systems in terms of fire suppression control and extinguishment and describes the components and specialized uses of water spray systems. So chapter 10 is referring to standpipe and hose systems. Standpipe and hose systems basically are available in NFPA 14. So classes of system, there are basically three types of standpipe systems: class 1, class 2 and class 3. Class 1 systems provide 2.5 inch hose connections at designated locations in a building for use by the fire department. Class 2 systems provides 1.5 inch hose connections at designated locations in a building for first aid firefighting. And you have class 3. Class 3 system combines the features of class 1 and class 2 systems. So basically you have type of systems: automatic wet systems, automatic dry systems, semi-automatic dry systems, manual dry systems, manual wet systems. You can go through these topics. Design restrictions based on system class and type. Number and location of hose connection. So basically if the question comes related to the hose system or the standpipe system, you can refer to this particular chapter 10 of section 16. So just we will go through thoroughly to we are getting closer to finish our session. Water supply and piping arrangements. Minimum flow rate and pressure requirements for standpipe systems are determined based on the class of system. This is an important what we can call paragraph. You just go through this. So pressure limits for standpipe system, they have mentioned for 1.5 inch 65 psi, for 2.5 inch it is about 100 psi. And apart from that you have various type of water supplies. I think this will be covered in section 15 as well, so there we can discuss. You have two examples of master PRV stations, pressure reducing valve stations. Apart from that you have system components, piping and fittings that can be used for standpipe systems. So you can see hose rack. This valve can be 1.5 inch or 2.5 inch based on the class. Typical hose cabinet with a glass cabinet is covered with glass. So here you have fire department connection. These are located where there are accessible to the fire department vehicles and not more than 30.5 meters from the nearest hydrant. So this is the small arrangement as per NFPA. You can see this riser consists of fire hose valve and zone control valve assembly as well. Standpipe system installation consideration. This is the fire department connection with a check valve. Commission of standpipe system pre-inspection acceptance tests, and you have fire department operations using standpipe systems, pre-planning, equipment operations, and so on. So basically this covers the hose systems and standpipe systems. Outside hose systems are not standpipe systems. This is an important point. So summary, we just have a look. Standpipe system delivers water for manual firefighting. This chapter provided an overview of standpipe system design and installation considerations. The chapter also included a discussion of the testing and inspection of standpipe system and fire department operations using standpipe systems. The chapter concluded with a brief description of the design and equipment consideration of outside hose system. So basically, if I say that if you have a good idea of summary of each chapter, you will definitely crack the examination. So finally we are going to discuss the chapter 11 of section 16, which is care and maintenance of water based extinguishing system. So basically section 16 is covering water based systems, from automatic sprinklers to water mist and ultra high systems. Apart from that, now we are going through the maintenance of water based extinguishing systems as well. So there are some basics which are available in this slide. Type of sprinkler system inspections: insurance company, fire department, sprinkler contractor, central station supervision. Maybe you might get a question from these particular topics in your examination. So frequency and timing and testing of inspection, testing criteria. This is also very important point or points highlighted here. Just go through. Dry type sprinklers must be tested every 10 years. High temperature sprinklers must be tested every 5 years. Fast response sprinklers must be tested after 20 years, with tests repeated every 10 years thereafter. Sprinklers manufactured prior to 1920 must be replaced. Sprinklers installed for 50 years must be tested and tested. A test must be repeated every 10 years thereafter. And these are all most important points. We have loaded sprinklers. Apart from that, since this covers the maintenance part, you can find all these topics here. So sprinklers and sprinkler piping, inspections, and so on. System size up to 300 sprinklers. Number of spare sprinklers you need to consider, that is shown here. 6 sprinklers up to 300 sprinklers. If the building is having more than 300 sprinklers to 1000 sprinklers, then the spare sprinklers shall be 12, and if it is having more than 1000 sprinklers, the number of spare sprinklers shall be 24. This is also very important topic. So you have so many things to learn. However, I believe most of the points are covered. Other sources of obstruction like microbiologically influenced corrosion, everything is available here. Flushing system piping, this is also an important point. Flow tests, visual examination. So basically cleaning methods, everything related to the care and maintenance is covered in this particular chapter. So in examination, if they ask about cleaning methods or flushing and so on related to the maintenance part, you just come to here and refer the topic. So generally there are two methods used for cleaning sprinkler system. One is water flushing and the hydro pneumatic. So sprinkler leakage, mechanical damage, freezing, overheating. Overheating is also another potential cause of accidental discharge from sprinklers, and is the term used when an automatic sprinkler operates as a result of abnormally high temperatures without the presence of fire. This is an important point which I highlighted. And you have several type of systems. Fire pumps also covered here, since this chapter is covering the maintenance. So this is covering the equipments as well, especially fire pumps. Electric fire pump should be run for a period of 10 minutes. Diesel pump should run for a period of 30 minutes. Water storage tanks also it is showing here. So this is the sample impairment tag also, you can use this as well in your installation. And here in summary, just go through of the leading causes of sprinkler system failures, 55% of those reported can be directly attributed to improper or lack of maintenance. So this is an important topic, so you might get a question from this particular chapter as well. So NFP 25 is covering the inspection part and testing and maintenance of water based fire protection systems. We have finished our today's session, which is a lengthy one. However, I believe that it is the most important section, since 20% of the questions in the examinations are from this particular section, and this is an easy topic or easy chapters also. We can easily identify the questions and refer the answers in this particular chapters. I believe you people understood these points which are discussed in the section. If you have any doubts or clarifications, or if you want me to provide any more details, just you can comment in the comment section, or you can personally email me, so that I will go through that and I will cover those things in my future classes. I hope you understand. Thank you for all of your time. I believe this course might be helpful for you people to pass the CFPS examination. Thank you. Bye.